We are diving into an explainer today that goes way beyond just, moving numbers around on a page. We're mastering exponential functions and visualizing some truly powerful change. We are essentially uncovering the hidden codes of how the universe grows and shifts. So get ready, because what we're learning today is going to completely change how you see the world around you. Let's get into it.
Psalm 147 verse 4 says, "He determines the number of the stars and calls them each by name." Have you ever looked up at the night sky and just felt totally overwhelmed by the sheer, vast size of the universe? It's completely mind-boggling. But here's the amazing thing. Even that vast, seemingly infinite expansion follows patterns, and that is exactly the kind of mathematical change we're about to study. We are literally looking at the math that models the stars themselves.
Here is our agenda for this explainer. First, visualizing powerful change. Second, unpacking the exponential formula. Third, graphing growth and decay. Fourth, a quick homework assignment to test your skills. And finally, connecting it all to education, morality, and peace.
Section 1. Visualizing powerful change.
Okay, before we even touch an equation, we really need to establish why these mathematical shapes actually matter in the real world. Exponential graphs are visualizations that show us exactly how fast things grow or shrink. They're dynamic stories. Like, did you know if you could fold a standard piece of paper in half 42 times, it would be thick enough to reach the moon? Yeah, that is exponential growth. It's the story of your phone battery dying rapidly or a sudden boom in a city's population. The shape of the curve gives you instant insights into these powerful real-world changes.
Section 2. Unpacking the exponential formula.
Let's look at the formula. Y equals a times b to the power of x. This is the absolute hero of our mathematical story today. And the crucial piece of this puzzle is that letter b. Just by looking at the value of b, we know instantly whether our graph is going to curve up towards the sky or dive down towards 0. If b is greater than 1, boom, we have exponential growth, and the graph curves upward. But if b is a fraction or a decimal between 0 and 1, we have exponential decay, and the graph curves downward. It really is that simple, and it's incredibly powerful.
Now you're going to want to memorize what I like to call the golden rules of exponential graphs. Know these, and you will never get lost. Rule number 1, these graphs never ever touch the x-axis, because y is never 0. Rule 2, they always cross the y-axis at your starting value, which is that letter a from our formula. And rule 3, they feature a horizontal asymptote. Now I know that's a fancy word, but an asymptote is simply an invisible line that the graph gets incredibly close to but absolutely never touches. Think of it like a mathematical force field.
Section 3. Graphing growth and decay. All right, it's time for the application phase. We are taking all this beautiful theory and putting it right onto paper. I'm going to walk you through a simple, totally foolproof 3-step process for graphing any exponential function you ever encounter. Step 1. Create a table of x values. Usually going from -2 to +2 or 3 works perfectly. Step 2. Pluck each of those x values into your equation to calculate your y values. And step 3. Plot those coordinate points and connect them with a nice, smooth curve. Follow these 3 steps, and you will nail it every single time.
Let's see how this builds with example 1. This is a growth function. Our equation is y equals 2 times 3 to the power of x. Our a is 2, so we start at the point 0, 2. Then, because our b is 3, boom, the numbers absolutely explode. The line curves upward from 0, 2 and gets incredibly steep incredibly quickly. It just rockets upward, getting higher and faster with every single point, all while our asymptote stays locked right down at y equals 0.
Now, let's shift gears and look at example 2. This is a decay function. Our equation is y equals 10 times 0.5 to the power of x. Our starting value, a, is 10, so we begin way up high at 0, 10. But our b is 0.5, so the curve gently, softly falls downward. It drops lower and lower, easing its way closer and closer to 0. But remember our golden rule, it never actually touches that horizontal asymptote at y equals 0. It just glides beautifully right above it.
Let's test this out with the function y equals 2 times 2 to the power of x. Try to calculate the y value in your head before I say it. Ready? If x is -2, y is 0.5. -1 gives us 1. 0 gives us 2. By the time x is 2, y is 8. Did you see how it perfectly doubled every single time? That, my friends, is exponential growth in action.
Section 4. Your homework assignment.
Okay, It's time to set up the independent practice phase to test your brand new mastery of these celestial curves. I highly encourage you to pause this explainer right now. Take a good look at these 5 specific problems. Practice graphing them out, identify your y-intercepts, find those horizontal asymptotes, and really figure out the shape of the curves. You've totally got this.
Section 5. Education, Morality, and Peace.
Now, I want to zoom back out from the math and the graph paper for a moment to discuss the much broader meaning of what we're learning today. As part of the Academy Godly Learner series, we believe deeply in intertwining biblical morality with education, and the reason for this is vital. Education without morality will ultimately hurt. Learning all the math formulas, mastering how to calculate exponential growth or decay, being brilliant and educated, all of that is truly wonderful, but it's really only half the equation for a good and meaningful life.
Romans chapter 8, verses 6 through 7 promises peace of mind to everyone who keeps their minds spiritual. This biblical promise directly connects to our experience of engaging with this content today. When you build a spiritual foundation alongside your academic foundation, you aren't just filling your head with facts, you're shaping a mindset that is grounded, purposeful, and filled with peace.
So, I'll leave you with this final thought. What really is the point of being smart and supposedly educated if we continue to make choices that hurt ourselves or others? As you grow exponentially in your knowledge, I challenge you to ensure your character and morality grow right alongside it. How will you choose to apply your education in the real world to build up rather than tear down? Keep that in mind as you tackle your homework, and I'll see you in our next explainer.